This video is about practice for Spearman's rank correlation coefficient. Spearman's correlation coefficient, RS, indicates the degree of monotonic relationship between two variables. Spearman's correlation coefficient is less sensitive to outlier than Pearson's correlation coefficient. If data items are equal, ranks should be averaged. Pearson's correlation coefficient is to measure the linear relationship between two variables, while Spearman's correlation coefficient measures the monotonic relationship between two variables. For outliers, Pearson's correlation coefficient is more affected by outliers, while Spearman's correlation coefficient is less affected by outliers. Hiller wants to measure to extent to which two judges in a gymnastic competition are in agreement. Each judge has ranked the 7 competitors, as shown in the table, where 1 is the highest ranking and 7 is the lowest. Calculate Spearman's rank correlation coefficient for this data. First of all, let's fill out this table. Normally, largest number is rank 1, but in this specific situation, 1 is the highest ranking and 7 is the lowest. So we need to put 1 as rank 1, 2, 3, 4, 5, 6, 7. Then if for the same number, we need to get average 3.5, 3.5, 6.5 or 6.5. 1, 2, 3, 4, 5, 6, 7. Then same number, 5, 5. 5 plus 6 divided by 2 equals 5.5. So we have 5.5 for each. Let's put over here. 1, 2, 3.5, 3.5, 5, 6.5, 6.5, 2, 3, 1, 4, 5.5, 5.5, 7. We will put this into calculator to figure out the Spearman's rank correlation coefficient. 1. No. Then add 4. Name the column A and B as P and Q. Copy in all the data. Move the cursor to any empty cell. Menu. 4. Enter. Go to 3. Use the right arrow button. P. Right arrow button. Q. OK. We are looking for this Spearman's rank correlation coefficient 0.817. R equals 0.817. E. State what conclusion Hiller can make from the answer in part A. We really need to look at what she is measuring. Killer wants to measure the extent to which two judges in gymnastic competition are in agreement. She is measuring whether these two judges are in agreement. 0.817 is a strong and a positive correlation. So the conclusion she can make is that two judges are in strong agreement. Guided practice 3. Charles wants to measure the stress of the relationship between the price of a house and its distance from the city center where he lives. He chooses houses of a similar size and plots a graph of price in thousands of dollars against the distance from the city center, d kilometer. Explain why it's not appropriate to use Pearson's product moment correlation coefficient to measure the strength of the relationship between price and distance. Look at this graph. It's not linear. We know Pearson's correlation coefficient measures the linear relationship between two variables. Because P and D are not linear. B. Explain why it's appropriate to use Spearman's rank correlation coefficient to measure the stress of the relationship between P and D. Look at this graph. You could say there is a monotonic relationship between P and Q because P and D have a monotonic relationship. Data from the graph is shown in the table. Calculate Spearman's rank correlation coefficient for this data. Look at 6 marks, which means you have to draw the table for the rank. Let's calculate the rank first. Highest value is rank 1, 2, 3, 4, 5, 6, 7. Same data is this. 5 plus 6 over 2 equals 5.5. 5.5. 5.5. 1, 2, 3, 4, 5, 6, 7. Now let's draw the table. This is P, here's D. For the rank, 1, 2, 3, 4, 5.5, 5.5, 7, 7, 6, 5, 4, 3, 2, 1. Let's go to calculator. On 1. No. 4. For column A and B, name as P and Q. Put in the rank. Put the cursor on empty cell. Menu 4. Enter. Go to 3. Linear regression line. Use the right arrow to get this P. Right arrow to get this Q. Then enter. We are looking for this R. R equals negative 0.979. D. State what conclusion Charles can make from the answer in part C. Let's go back to the goal for Charlie. Charlie wants to measure the stress of the relationship between the price of a house and its distance from the city center. Conclusion is that there is a strong negative relationship between price and distance.